Exercise 3.3 problem 1 division 8 solution. Find the zero of the quadratic polynomial and verify the basic relationship between zeros and the coefficients of x square plus 2x minus 143. Okay. Let p of x be x square plus 2x minus 143. We need to factorize, that is coefficient of x square is 1, 1 into the constant is minus 143, which needs to be factorized in such a way when you add that factors you have to get add or subtract, you have to get the coefficient of x, which is 2, right? So 143 can be split as 13 into minus 11, and 13 into 11 is 143, 13 minus 11 is 2, so it fits the bill. So the factors are 13 and minus 11. Say here it is showing the details are given here. 13 into minus 11 is minus 143 and 13 minus 11 is 2, right? So next we have to divide this by the coefficient of x square, right? That is 1, and this is minus 11 divided by 1. So 1 is the coefficient of x, so it is 1x or x, and this is the constant term, so plus 13. So this is 1x and the constant term is minus 11. Please understand the numerator is a constant term of the factor and the denominator is the coefficient of x in the x of the factor. Okay, so this is 1x plus 13, which is x plus 13. Similarly, this is 1x minus 11, that is x minus 11. So the factors are x plus 3 and x minus 3. So p of x can be written as x plus 13 into x minus 11. So equating p of x to 0, we get these factors are also 0, which means x plus 13 equal to 0 or x equal to minus 13. Similarly, x minus 11 equal to 0 or x equal to 11. So these are the two zeros. Okay, that is x equal to minus 13 and x equal to 11. Now, we can check out the zeros. Earlier we used to substitute those values zeros in the original function polynomial. But now what we can do is that the alternate is that you can substitute that in the factors also. That is another way of doing this. Is little easier. We'll try this. Whichever appeals to you, you can do. So when you put p of, let's find p of 13. So you'll have to put x equal to 13. So this will become minus 13 plus 13. This is x is 13, right? So this will become 13 minus 11. Minus 13 plus 13 is 0. 0 into anything is 0. So this factor is right. Next, p of 11. So substitute x equal to 11 in this expression. So it will become 11 plus 13 and 11 minus 11. Again 11 minus 11 is 0. 0 into anything is 0. So this is also right. So the zeros of the polynomial are minus 13 and 11. What's the next step? We'll have to prove the basic relationship, right? Right. So let's get into that. We found the zeros to be minus 13 and 11. So what's the sum of the zeros? Minus 13 plus 11, that is equal to minus 2. And product of the zeros is minus 13 into 11, that is minus 143. Now what is the polynomial? It's x square plus 2x plus, minus 143. Coefficient of x square is 1, coefficient of x is 2, the constant is minus 143. The sum of the zeros is minus coefficient of x divided by coefficient of x square. This is a relationship. Now let's check. Coefficient of x is 2, so it is minus 2 divided by coefficient of x square is 1 in this case. So minus 2 divided by 1, that is minus 2. As you can see, we got minus 2, and coming from the zeros also we are getting minus 2. Next, product of the zeros is constant by coefficient of x square. The constant in this case is minus 143. Coefficient of x square is 1. So it's minus 143 divided by 1, which is minus 143. Okay, and that is what they have also got it when they calculated from the actual zeros. So the relationship is also proved, right? So whichever way the substituting to check the zeros, you can substitute in the factors and check it out, or you can substitute in the original polynomial and prove it. Whichever way suits you, you can do. Okay. Thanks for watching this video.